There isn't one Bitcoin blockchain, there are at least four. One holds real money. Three are shadow networks where developers break things on purpose. If Bitcoin's whole point is one global ledger secured by proof of work, why do its developers need a permissioned version to ship code? To understand why three test networks exist, start with the problem they solve. Shipping buggy wallet code to mainnet means real losses. A misplaced decimal, a malformed signature, a corrupted address, and someone's life savings vanish. Developers need a sandbox where coins are worthless and the mistakes are free. Bitcoin Core ships with three of them, each tuned for a different point on the trust spectrum. Regtest, where you trust yourself, Signet, where you trust signers, and the testnet 3, where you trust no one. Testnet 3 is the original sandbox. Permissionless, fully featured, restarted in February 2011, now over 30 gigabytes. Anyone can mine it, anyone can spend on it. To prevent costly mix-ups with real coins, test addresses use different prefixes. Mainnet legacy addresses start with 1. Mainnet pay to script hash starts with 3. Mainnet segwit starts with BC1. On testnet and Signet, those become M or N for legacy and TB1 for segwit. Same software, same consensus rules, different prefix. Send testnet coins to a mainnet address by accident and the wallet rejects it before the transaction ever broadcasts. Testnet has a fundamental flaw, and it isn't technical, it's economic. Bitcoin security depends on real incentives. Miners burn electricity because blocks are worth money. Remove the money and the proof of work alone doesn't keep the chain useful. Goodwill miners include real transactions, but a single disruptive miner can flood the chain with long runs of empty blocks, drive difficulty into chaos, and lock developers out exactly when they need stability. Testnet becomes unreliable, wallets stall, test transactions sit unconfirmed for days. The sandbox breaks at the moment you most need it. Testnet's problem is economic, and that's why Signet was invented. Defined in BIP 325, Signet trades permissionlessness for reliability. Every block must include a signature from an authorized signer. The block header carries a challenge script. If the signature satisfies that script, the block is valid. If not, every node rejects it. The challenge can be a single key or a multisig. Your choice. This eliminates the empty block attack completely. Disruptive miners can't produce blocks at all because they don't hold the signing keys. The chain stays stable, difficulty stays sane, and the developers get something testnet hasn't delivered in years, a predictable test environment. The default Signet, run by Bitcoin Core contributors, sits around 150,000 blocks and roughly 1 gigabyte. It powers Bitcoin Inquisition, a fork that tests proposed consensus upgrades like new opcodes and covenant primitives before anyone dares deploy them to mainnet. If you want full control, launch a custom Signet with your own challenge script. Pick a multisig of your team, generate a fresh genesis, and you've got a private, stable, signed test network that behaves exactly like real Bitcoin, minus the money. Regtest is the third sandbox and is the most fun. No network, no peers, no syncing. Boot Bitcoin with the regtest flag and you've created a private Bitcoin universe on your laptop. You control difficulty, you control block times, you control the clock. Mine a block whenever you want with a single Bitcoin client command. Want to test a transaction confirmation? Mine one block. Want to test a long time lock? Mine 10,000 blocks in a few seconds. Regtest is not a slower testnet. It's instantaneous, local, and answers only to you. Here is the most visceral demo. Mine 500 blocks on regtest. It takes about 2 seconds, but you cannot spend all the rewards immediately. Bitcoin's Coinbase maturity rule says newly mined coins are locked for 100 blocks before they can be spent. This prevents real chaos on mainnet, and regtest enforces the same rule. So out of 500 mined blocks, the most recent 100 are immature, and the first 400 are spendable. Now each block pays a subsidy, but on regtest, the subsidy halves every 150 blocks. So across the first 400 mature blocks, we actually cross two halvings. Blocks 1 through 149 pay 50 BTC each. That's 7,450. Blocks 150 through 299 pay 25 each. That's 3,750. And blocks 300 through 400 pay 12.5 each. That's 1,262.5. Add them up and you get 12,462.5 BTC. Averaged over 400 blocks, that's about 31.15625 BTC per block. So roughly 12,462.5 spendable test coins in 2 seconds. 3 misconceptions was killing now. First, testnet coins do not have value. Their worthlessness is a security property, not a bug. Falsely distributed, freely mined, deliberately disposable. Second, Signet is not centralized in any way that matters. Block production is permissioned. Consensus rules are identical to mainnet. Signers cannot steal anything because the coins are worthless by design. Third, regtest is not a slower testnet. It's not a network at all. You're not connecting to anyone. The whole chain lives in your machine's data directory and disappears when you delete it. Real developers use these 3 sandboxes together. The pipeline goes regtest, then signet or testnet, then mainnet. Write your wallet code on regtest first. Iteration is instant. Mine blocks on demand. Reset state with one command. When the logic holds, move to signet for real network conditions, actual peers, actual propagation delays, actual mempool dynamics, but a stable signed chain that won't fall apart mid-test. Some teams use testnet here instead, accepting its instability for the wider faucet ecosystem. Finally, deploy to mainnet, where every transaction costs real fees and every bug costs real money. Each step trades speed for realism and realism for risk. This pattern, local sandbox, shared staging, production, is now the template every serious blockchain ecosystem copies. 4 chains, 1 holds value, 3 hold lessons. Mainnet works because the incentives are real. The test networks work because their developers were honest about which incentives could be removed and which had to be replaced. That asymmetry is the quiet architecture behind every Bitcoin wallet you trust.